Hi, my name is Yimi. Today I'm going to present the design process of an Arduino-based electronic voting machine. The aim of this project is to create a simple, secure, and accurate electronic voting system using 3 push buttons along with lock and reset function and result display through Arduino coding. In this system, each push button represents a candidate. When a button is pressed, the Arduino detects the input and increments the corresponding vote count. To prevent multiple voting and ensure security, a lock function is implemented which disables all voting buttons once the voting process is complete. A reset function is also provided to clear all vote counts and prepare the system for a new voting session. The voting results are displayed using code on an LCD, showing the total vote received by each candidate. This Arduino-based electronic voting machine is cost-effective, easy to operate, and suitable for applications such as school elections, college projects, and small-scale voting systems. That's all from me.
Now I will present about the flowchart of the coding of the Arduino. So at the very first of the code, the value of vote A, B, C, D will be set to 0 and the LCD will display the candidates A, B, C, and D. And then it will enter as a loop and start determining whether the lock button is pressed or not. If no, the Arduino board will detect if there is any voting button is pressed, such as if button A is pressed, then the vote A will undergo an increment of 1. And for another example, if button C is pressed, then vote C will undergo an increment of 1. Okay. If the lock button is pressed, then it will undergo a decision whether if any vote is bigger than 0, which means that every button is pressed or not. If no, it will back to the voting loop. If yes, it will start determining which vote have the biggest number. For example, if vote A has the biggest number, it will display A wins and the codes end. And for another example, if vote D have the biggest number of votes, the LCD display will display that the candidates D won the voting and the codes end.
Electronic voting systems are widely used in many real-life situations today. One of the main applications is in national and local elections, where electronic voting helps speed up the voting and counting process while reducing human error. Besides that, electronic voting system is also commonly used in universities and schools for student representative council elections because it is more efficient and easy to manage. In corporate sector, companies use electronic voting during annual general meeting, allowing shareholders to vote remotely without attending in person. Electronic voting systems are also useful for overseas voters, military personnel, and people with disabilities, as they are making voting more accessible for everyone. Overall, electronic voting systems improve efficiency, accuracy, and accessibility, making them suitable for modern decision-making process.
Hi everyone, my name is Haziq and I will tell a little bit about lesson learned and challenge faced. Through this project, we learned how to interface hardware components with Arduino while embedding C program and troubleshoot circuit and coding errors. We also understood the importance of accuracy, reliability, and security in electronic voting system. Some of the challenges we faced during the project include button debalancing issue, wiring error, power supply stability, and ensuring correct vote counting. In conclusion, this Arduino-based electronic voting machine is a simple, cost-effective, and reliable prototype that demonstrates the basic working of an electronic voting system. It reduces manual effort and counting time and can be further improved by adding security features.
This is the circuit of our voting machine using Arduino processing board. As you can see, the wires are attached to the plot that they are supposed to be attached to, and the circuit are all attached to the ground node. And this is the LCD display of our voting machine. And this is the Arduino coding that we code for the Arduino Uno processing board to process. When we press start, the Arduino board will undergo certain process and give signal and to the LCD display as an output.